Here's what's up. So today we're in here for almost an hour and a half because tomorrow you won't have math, and trust me, it'll go by quickly. And you'll have Mr. Smith instead of me. Once he gets down here, he was wrapping up 8th grade gym, I believe, because they have a really funky schedule this year with when kids had to do certain things. But today, 713 is more application of the same sort of stuff we were doing yesterday. And then 714 kind of takes it to a little bit of a further point than where we were yesterday. But 713 is pretty much all the same stuff we were doing. So the first problem we're going to talk about is 27. But before we get there, we want to talk about scale factors really quick. A scale factor is any value, because I feel like kids get stuck on it being a particular thing. Give me your eyes. I got a lot of people moving. Just give me your eyes for a minute. A scale factor, as we start talking about this lesson, is just a multiplier. So I would like, if you could write down in your notes really quick, scale factor is multiplier. Anything you're using to multiply with can be called a scale factor. If we're talking about 25% and we use 0.25, that's a scale factor. If we're talking about 25% and we use 1/4, that's a scale factor. If we're talking about 25% and we use 25 over 100, still a scale factor. Could be reduced, but still a scale factor. So scale factors are multipliers. Then, go ahead and look at 27 and start that with your team. And Mr. Smith is going to take over the reins from here. Thank you very much, Mr. Smith.
We're just kind of setting that this first lesson until about the normal or how fast it's transition. I told them we might just get through the lesson. If they're working and staying on it, I'd say just keep the pace.
Natalie is very mad at you.
Oh my god, why would I be mad at it?
Because you're mad at me.
You were yesterday.
Oh
Boy,
yeah.
my friend that had that whole conversation, he was like, your friends are weird. My friends are weird. And then he's like, my brother was like,
I first
Hey guys, you should be talking about Hugo.
Who's Hugo?
If you don't know who Hugo is, you're already behind.
oh, they're supposed to go like, guys.
If you don't know what to do for a diagram, you can try. The one I've got up there is very generic, but you can always start there. $0, 0%, because that's the problem. Well, okay, yes. I'm sorry. Yes. So technically you cannot give more than 100%. So when coaches say you should give 150%, that's technically
No.
But
Like coaches when they say that. No, they
you
might
can.
slap
They
you.
might.
They would slap you and yell at you.
To answer your question, a price can go up by 1,000%. If something that used to be $1 goes up 1,000%, it now costs $1,000. It would be very unlikely. But
What if it was 1 cent?
Okay, so what is 100%? Somebody who's got a little further on their line graph. 245. It tells you at the top.
Oh, right. Nice.
Guys, ladies, Sophia, the three of you and the two of you have one morning. Okay, we're in here for an hour and a half now. Okay, so we're going to spread out and we're going to have different groups. If you can focus. Okay, you should have a line. You should have $245 on it. I don't want to answer your question until you write something down. Okay, what is the deal? Somebody again who's already got with their group a little into this problem. How much are we either paying or how much are we getting discounted? So, Joey says 60% discount, that means we're paying 40%. So, where should I put my line here? On the bottom? Well, I was going to go right through. So, should it be bigger than half or less than half?
Bigger. Bigger.
How much is the discount? Is that more or less than half?
More.
And that's a discount. So is it coming off of the price or is it coming off of the zero? The discount's coming off the price, right? So we want to be a little to the left of halfway. A little to the left of halfway. Okay? You can label this a couple different ways. Some people like to label their gaps. So this gap is a 40% gap. Oops, wrong side though. I probably should put that below the line. Right? Okay. That's about all we know though.
So he paid 40% of it.
He paid 40% of the price. So Aiden just basically solved it for us. If we can translate Aiden's statement, which is 100% true, into a math statement, that's all we got to do. So can you say that one more time?
I said, so you only paid
40% of the price. And what is the price?
245.
That's the answer. Okay? Well, it's not quite the final answer. But by simply stating,
Because it says of.
okay, of translates into multiplication. Okay?
Negative 4%. 400 over 40.
Riley, what would you put for 40% if you're going to go into a calculator? 40? That's going to require more math eventually. Yeah, if we go with .40, then we'll save ourselves a step.
4 over 10.
So, 40%, remember, 0.40. Do we have to do anything to the money when we type in the calculator? $98.
He paid $98.
Sorry, I'm both left-handed and the board is fading, but that is a $98.
Your dot is very large.
That's a multiplication dot. That's okay.
Yeah.
All right, so we kind of got rolling there, and I didn't really look at all the parts of the question. Did we actually answer them all? Drew a diagram, yes. What will his result represent? 40%. I think we covered that. Scale price was the 40, or the .4. And then find the sale price of the bed in two different ways. That is using two different multipliers or scale factors. How do your answers from your two methods compare? So what if you didn't realize right away? Some middle schoolers I've noticed kind of jump right into things and sometimes don't stop and think.
Not all the time, not all of you, but it happens sometimes. And somebody might see that 60% immediately go, boom, 60% of 245. Are they okay?
No. Yes.
They're not.
I am 100%
They're-
okay.
They're not going to get the answer yet, but they don't need to start over. What if you did 60% of 245? What's that one extra step then that you've got to do? Right. So if you get into one of these situations and you accidentally find 60% first, no big deal. Just subtract it from your total. So, does anybody know what 60% of 245 is?
Now, Mr. Smith wasn't in here yesterday, and I can't remember if I emphasized this as much with you guys as I did with the other group. What's a really nice shortcut that we can use for most all percent problems? And you like barely have to do math, you just have to move something.
Yeah.
Oh, the decimal point.
The decimal
Yeah, but what? It was to find the 10%. Now that was Ethan did that yesterday on like one of our first problems. So remember here, whether you're using 40% or 60%, if you find your 10% first, you can work from there. Now I get it, here it would be a decimal, be 24.5, but still that's not that hard of a number to work with, right? So your 10% is always your shortcut method. Cool? I just wanted to pop over and remind you guys of that, because on any percent problem that is a multiple of 10, 40 and 60 are both multiples of 10, you can use the 10%. Super easy. Just wanted to pop over. Thanks, guys.
Yeah, Brody, you got a calculator in your hand right there. What is 24.5 times 4? Because that's our 10%. We want 40% though. 4 of those equals? I hope so. Your calculator tell you 98? Good. All right. Fine.
It's just 0.1 times 245.
Oh, that did not work, but it was supposed to be 1. Like, just move the decimal. For 10%, just move the decimal 1 to the left. Okay. So, on to 28s. Up on the top screen, we've got Hugo now with his older sister, Sandra. Okay. And she had a summer job for the last 2 years. She worked the entire summer. Okay, check that out. $3,000 earned in one summer for Hugo's sister. She's getting a raise. Skylar, who's getting a raise?
I don't know.
Oh, shit.
Hugo's older sister.
Pick a new spot. I already warned you. I said if I have to talk to you again, I was going to move you guys apart. So go find another spot. Pick up all your stuff. So, who is getting a raise? Hugo's sister, a.k.a. Sandra. And she is working, okay, for a 6% increase. We can see the diagram up on the top screen, but let's go ahead and copy it onto our paper since that's what the directions tell us to do. And if we look at this one, the 100% is not at the end. That's weird. 100% is right here. So here's your 0. Yeah. So this goes back to Sophia's question of oh my gosh, seriously? Try this one more time. That is not a good 100. It is way off.
Press the 2. Do you know how to get it straight on? Do you know how to get it straight again?
I know I can do the whole top corners, but I'm going to try to manage through this problem, and then I'll try to reset it while you guys are working. Okay, so what is the full line then?
106%.
Yes. There's something about that. I feel like that is not usually obvious. Maybe the diagram helps.
Yeah, I don't understand. That hurt your shoulder?
Right, raising your hand. Hold on, before I do, what can we label on the top?
Money.
Yeah, so $0, that's easy. Where's the 3,000 go?
What percent?
Over the 100. So,
Because she's rich.
so last summer, the 100% is last summer's salary, right? 100% is last summer's salary. This summer it's going to be more, right? It's a raise. How much more? 6% more. So what do we want to know?
We want to find 6% of 3,000.
6% of 3,000. That would work. What's 6% of 3,000? Ethan?
0.06.
Oh my god.
Times.
Be careful here. What's the trick? What will you make in this? Yeah.
It's 180. It's 180.
Okay.
80.1.
All right. So.
Then you add the 3,000 plus the 180, and that's.
All right. What did Brendan just point out there, Casey? That's really important. We've got our equal sign says 180, but that's not our answer.
What?
What's our last step?
What? This is the most confusing one.
We get it because 6 times 3 is 18.
What?
Casey, where does this 180 go?
It has to go in the 106% area.
Is $180 106% of?
Wait, how is that a raise? Go
The
from $300
$180 is a true fact. Oh my goodness. I was doing a little better there for a second. Okay, so we'll use an arrow. How about that? Still not working that well. The 180 is just this little area right here. So the 180 is just that little bit past the 100%. So Brendan already said it, but somebody reiterate. What is the amount that she will make this summer? $3,180.
That's not a lot of
Okay.
dollars.
$3,180. Kind of depends on how many hours she's working and things.
$400 per week.
If that was going to be for a whole year, that's about $12,000, which is a lot for a high school student or something. It would not be a lot for an adult necessarily. All right. So, can someone tell me a quicker way to do it? This way works. If you like this way, it will work for you every time. But there's one way you can do a single enter into your calculator for the answer. What could we do in one step? It goes back to what Sophia said about 106%.
Oh, you added.
What do? We move the decimal 2 places, 6% of 180. But is she making 6%?
No, she's making 106%.
She's making
We have to
106%.
add the 3,000 and the 100.
Can we use that number? 106%.
Yeah, you can use that number.
What would it be as a decimal? 1.06.
Well, really, it's not that much money for working the whole summer.
It kind of depends on how many hours she's working, things like that. Somebody, anybody with a calculator, please type in 1.06 times 3,000. Somebody without a calculator, tell me what the answer already is before they even get done.
3,180.
I already got that.
Okay.
Did.
Anybody with a calculator disprove this theory here? So,
Jalen said it with a calculator.
yes, that's fine. You're allowed to. I was just saying we want to know.
Somebody without a calculator.
We want to confirm, right?
Okay.
So what are our 2 scale multipliers then? Ooh, that's a vocabulary question. Good guess. Last question question, I'll let you guys get going on a few here on your own. What are the two scale factors you could use? What's one of them, Joey? 1.06 is one of the scale factors you could use. What's the other scale factor you could use? It's the one that requires an extra step, but it still works. What's another scale factor? You can use 106%, or you could use not 0, but closer to 0. Yeah, you can use your 6% as well. There's your two scale factors. Okay? All right. If you have questions on the next one, raise your hand. I'll come around, or I'll put it quietly up on the board. But I'll let you guys try to work through this one with your group.
No.
Can you do what?
No.
No, I'll do that while you guys are working. But thank you for offering.
I write too big. Wait,
Where's the realign button?
no, I got it.
Okay, so you should be on now 7:29.
That's my
Summer's like but it is a lot of money for us. $23.
I will show you. No, this is not.
After this problem. Yes. Well, and 12.
Oh my goodness.
100% grade.
It's so satisfying. Oh my god, can you picture that hard without there being fun? Actually, be hard. It's not. It's
Okay, Marina, I've talked to you 7 times.
Bro.
Time. Okay. 9.375.
no.
That word doesn't mean word.
Okay. Most of the groups have figured out her new hourly salary. Not sure, let me know.
I don't know how to make a graph.
There.
Well, okay.
Wait, no.
So you get a 100% raise. 100%. Right. So how much?
Mr. Smith! I said your name was what?
Are you a bird? Yours, yes,
You don't even have a shape of your eyebrows.
All right.
You're a bush. Yes. We're not. Yes.
Did it work?
It was so long since I recorded. It was like your icon was last weekend.
Yay.
Mr. Smith,
Yes.
it's like a parent.
Oh my god.
Grace, that means
Is
That child is a child abuse system.
Andy does not necessarily want to do
Wait,
it.
yeah, I was pretty good hand.
No, I said it's not. When it's a parent and child, there are exceptions. So, the hard part of part A, most people got the $25 thing. What percent is $25 of the original amount?
1/4.
No.
Wait. 100%. Wait.
What percent is that of the original?
100%.
No, it's not 100%. 200. So, part A. Okay, time out. Skylar has identified correctly. In part A, a lot of people only put the $25. The other part of the question is, what percent is that of the original? And because it's 100% more than 100%, it's 200%. Okay? For part B, anybody started part B yet?
9.375.
Hold on.
Gosh.
I need a calculator.
With this question, part B, it says she was offered a raise of 75% to teach a private lesson. Is that 75% of the $12.50 or of the $25? Or does the
doesn't specify.
It says of her hourly rate.
It doesn't
It
specify.
doesn't specify.
It
Yeah.
doesn't specify.
I think you can read it either way. How many people have already started this and used 1250 as the amount? Anybody use 25 as the amount? No? Okay, let's use 1250 then. We'll go back to the original.
Oh, it's beautiful.
Yeah. You need a half a penny? Yeah, you're right. Does that happen in real life? Yes and no. Sometimes it comes out like that, and then what is the business going to do? Like if you owe $10.51.5, are they going to round up or round down? They'll probably just round up to the next cent, right? So, all right. So, ladies and gentlemen, 75% to teach a private lesson. So it's 75% of 1250. So what does the calculator want you to say then, if you're using a calculator?
0.75 of 1250 equals 9.37.
Well, there's not an of button. What's the of button?
Multiply.
Yep.
Equals 9.375.
Okay. Brandon already brought it up. In real life, sometimes the math doesn't come out perfectly. She's charging $9.37.5. Okay? So, if she only works for an hour, okay, if I am paying for the piano lesson, what is she probably going to tell me I owe her?
Money.
Yeah, is she going to say that I owe her $9.37, $9.38, or $9.37.5?
$9.38.
She'll probably round up to 38. She's the one making the money. And as a consumer, as the customer, I'm not going to probably whine over half a penny. And I also am not going to cut a penny in half, because then it's not worth anything.
Can I cut a penny?
She doesn't give piano lessons.
It's not piano lessons. Oh, gymnastics. If I go to a gymnastics teacher for piano lessons, that could be all kinds of awkward. All right, good call there, Ethan. All right. So part C asks us again to figure out which number they're talking about. Relationship between the raise and the new pay as a percent of the original pay. How is this related to the scale factor between the original pay and her new pay? So, are we talking about the 75% raise or the 100% raise? Are we talking about the 1250 or the 25 or the 937? It's not real clear. What do you think for part C? Did anybody already plug some numbers in for part C? Anybody get that for you?
Part C?
Part
Nope.
C.
I didn't even read it.
Relationship between percent raise that Marana gets and her new pay as a percent of her original pay. Let me see what they chose to use. By the way.
Your hair looks like Big Bird.
Oh, this is scary.
729. All right. So, going back to part A, what percent is the multiplier? How much did she gain in part A? 100%. That's all they wanted for part C. 100% of the original, so the scale factor is 100%, or the multiplier is 1. Multiplier is 1. All right. Move on with your partner, with your group to 7:30. And it looks like this might be our last one before we transition to the next lesson. Yes. Once we get done with number 30, we can move on to the next lesson. If we get done with that, we can move on to doing homework and getting it done. Okay, we're doing 30 with a partner, with a group. On your own if you're feeling really confident. You just need to do, yeah, she was just 100%. Let's see, it says if you don't agree, write and solve a new equation. The number that we're looking for is 50. The number we're looking for is 70. Is it related to Mama? Ah, cool. Okay. Okay, the things in blue on the board should be on your paper as well. This is just the diagram. Then, if you haven't read the problem yet, you need to read it again and figure out if this diagram agrees with the equation 72 times 0.14. And if it doesn't, you need to write a new equation. It might help to label some more of the diagram first. So you might want to finish labeling a little bit before you try to type anything into the copy.
I see what you did there.
Have you ever gotten yelled at in a movie theater for talking? No. I have. I'm done. I'm done with this.
Done, done? All right. What is this? What is this? 86%. Okay. So, let's see. Guess these might be y'all.
Or yellow.
Yep. All right. Skylar, you're on top. Where did the 86% come from?
Because you subtract 14% from 100.
Awesome. Ladiva, did you hear that? Yep. Okay. So, Skylar correctly pointed out 86% is that unlabeled part. Because we know that there's 100%, and they tell us there's a 14%. What do we want to know 86% of? Of $72. So, Laviva, what does that look like in a calculator then? And did you already figure that out? What does that equal? $61.92? Okay. Isaac, where on the little graph is 61.92? The X spot. Great. Okay. Madison, where or what is this one unlabeled part? Or if you haven't figured that out yet, how could you figure it out? This little area here. It's what? Exactly. 10.08 or $10.08. Very good. All right, that's not going to come out very well, but that's 10.08. It all adds up to 72, and we are all done with 7.1 points. What is this one? 3. So, we're right on track. Lesson number 2. This is usually when you guys would go to ELA.
No,
Okay.
I want to go to ELA. What?
There's
This is only
math happening in
the first
ELA as well,
class.
so there's no
We can't watch
escaping.
the movie.
Okay. Now you're gonna watch. I think you're gonna watch the whole movie tomorrow.
I don't. Oh.
So we're doing math again.
Yeah.
This time it's 714. Right? And for 714, if we go through this, it's kind of similar. I think we can go a little quicker, and then you guys will have some time to do your homework. Okay? So, time for a new heading. 7.1.4.
You're gonna make her mad at you saying that. Got it.
A bunch of people. A bunch of people.
All right. So, starting a new heading. You can do it however you generally start your notes. Okay. Pretend like you're starting a new lesson, because that's what we're doing. Okay, so for your label, your heading, you can call it, well, there's not really a way to write that in a shortened version, really, because you've got equations with fraction and decimal coefficients. So, I'm messing that up. Somebody help me out. What is the coefficient? Oh, I should go back to sorry. All right. Aiden. Do you remember what a coefficient is? No? Adrian is. Layla, what is a coefficient? Coefficient. Kevin, you remember what a coefficient is? Not really. Okay, go ahead, Riley. What's a coefficient?
Okay, so I'm not sure, but I think it's like when a number has like no, like an extra thing. No, wait, okay.
Riley, could you? Is there a coefficient anywhere in that line? Can you tell me one coefficient that's in that line? Okay, 3x has a coefficient. What is the coefficient of 3x?
3.
It's 3.
So, guys, what does co mean? Kevin. With, together, right? Co-efficient. It's together with the variable in this case, or with anything. You can have coefficients on other stuff. But when we talk about coefficients, it's with. It's together.
So 6.
So what?
I don't know.
So if you had like 6 times like purple, whatever your 6 is your coefficient. It's multiplying with it. But you good, Mr. Smith? I just wanted to check over
Yep.
here.
Yeah, we're just now starting the second one.
You're good.
So, in this case, 3 is the coefficient, 4 is the coefficient, 2 is the coefficient. So, here's the deal, guys. This lesson is nothing new, but it's going to challenge you a little bit because what it's combining is what you guys did before break when it was like remember what is like 3x plus x when you combine like terms. What's 3x plus x? 4x. And you guys have already done before fractions, decimals, and percents, right? So what is 3/4 plus let's just make it easy. What's 3/4 plus 2/4? 5/4, right? So, what we are now doing is 3/4 x plus 1/4 or 2/4 x. So, it ends up being part of an x. You're going to end up with parts of these variables.
How do you have part of a number you don't know if you don't know what it is?
Well, and that's a great question. You won't know. So you're going to end up with, okay? I tried to, and I kept doing something. Oh, that would be easier. See, that's why you get paid the big wage. So, ladies and gentlemen, real quick then, before we get into the actual problems here. Look at that first paragraph. It's just saying throughout the course, you work with fractions, decimals, percents. All right? Each represent the same, even though they look different. So these all equal the same thing. With algebra tiles, we've done different things. X squared plus x, we can see that they don't go together. They're not like terms. We've seen things like this and combine them. Okay? So all we're doing differently, and we're getting into those kind of things where, I don't know if you've ever seen a TV show or a movie. Have you seen a TV show or a movie where there's a scene where there's a random like math class and it looks like it's got really difficult problems written on the board?
Yeah.
Those are the kinds of things, that's what they're going to look like to people, like possibly your parents, if they haven't done things like this in a long time. They might say, oh no, there's a 2/3 x squared, and it's going to be intimidating if you haven't done it in a while. But you're you're going to relax because you know what fractions are. You know what coefficients are. You were reminded now. And you know what combining like terms is. So, we are not learning any new rules. No new rules, but we're going to get into some more complex problems. So this first one, go ahead and label it on your paper, 7-39. Okay? And for this one, let's get this first one going, and then you should be able to go on your own from there. Aiden, do you want to read this first question next and left?
Sure.
The Sutton family took a trip. Sorry,
Hush. Just go.
The Sutton family took a trip to see the mountains in Rocky Mountain National Park. Linda and her brother Lee kept asking, "Can you guys stop talking?
Are we there yet? At one point.
Are we there yet?" At one point, their mother answered,
Hold on, guys.
I can do those things.
We're still reading the problem. If you've gone ahead, it should be silently. Okay? We're not discussing the problem yet or anything else. So they're going on a trip. They're asking, are we there yet? Continue.
At one point, their mother answered, "No, but what I can tell you is that we have driven 100 miles and we are about 2/5 of the way."
All right, Aiden, continue from there. Linda.
Anyway, not away. They each started thinking about whether they could determine the length of the trip from the information they were given.
Thank you.
Linda's method, yeah, and then Lee's method. Lee's method is dumb.
All right. So,
Oh, ew.
explain how both Linda's work and Lee's work illustrate the situation described by their mother. What does X represent in each diagram? Okay? So, go ahead. See if you can fill in A. If you're not quite sure, you can skip to B and see if that's any easier. And I'm just going to give it, we'll make it short on this first one, and then for the rest of it, it's going to be mostly on your own.
X represents
Excuse me. My pencil won't sharpen.
So if you haven't done anything yet, draw the diagrams. That's what I'm going to be doing as well while you're working through this.
wait.
It's up top, but remember, you can always get a book if you can't read up there.
No.
What number is it?
739.
Even you're like,
Dang, he's so hard. What?
Okay, if you have not yet drawn the two diagrams, I do not want to hear a word. Talk when you have drawn and labeled both diagrams. I will know you are finished drawing when I start to hear voices talking about the answer. But the first step is drawing it. You don't need to talk for that.
1, 2.
Sure it's labeled too, please. When it's drawn and labeled, you're talking with your partner about what X represents. And Layla, you've got the first try at this. Do you have any idea what the X represents?
No. Wait, how long the trip is? I got him. I was right. Oh my gosh, good job, Bella. You're actually right. That's really
Okay. Layla has identified correctly that in both diagrams, the X represents the total distance of the trip. For part B, we're looking for an equation that could do this. An equation. So, see if you can figure out an equation that will work. For part B. Alright, Kevin, you have an equation? Your card is next, so I'll come back to you. Joe, you have an equation? What do you got?
Which one?
B. Part B. No, you don't?
No.
Okay, Brendan's going to take a shot at an equation here.
100 divided by 2
Okay.
equals X.
Yes, but I am going to set it up a little differently, and you'll see how they connect. But yeah.
I know, it's so weird. I'm cold.
I think I was not back there.
Yes.
Wait, early.
Ah, interesting. Okay, first of all, before we get into the scale factor and everything, let's talk about all those problems we just did in the last lesson. Go all the way back to like that mattress one, right? It was 40% of 245 or whatever it was. Okay? We don't have a percent here, we have a fraction. Alright? And it's 2/5 of what? 2/5 of the whole trip, the total distance. Okay. I don't feel like writing out, again, I've already done it once, total distance or whole trip. So what can I write instead? 2/5 of X
Equals. So then we just have to do
is what? 2/5 of X is what?
2/5 of X.
2/5 of X is 250?
No.
No.
100.
100.
I'm calling the call. How do you know? Oh!
So, time out.
No, 2/5 of X is 100 miles. Oh!
So, this is not This is not a, it's not a trick problem. This is actually, even now, at almost 39 years old, how I still figure out percent and fraction problems like this. I say it out loud. Okay? When you say it out loud, the math starts to become clear. We want to know, and we can see it up here, 2/5 of the whole thing is 100. Okay? If you look at the triangles, you've got the big triangle X, and then the little one is 100, and you see the times 2/5. So, Kevin, what does the word of tell us to do? Right. And also, Kevin, do you know what the word is means in math symbols? Equal to.
Jesus.
Now, Ava, here's where things get a little bit murky. You're next. You have the next question.
Yeah,
You want to be on?
You got this. You go, Jack.
If the problem was just 2 times x equals 100, what will we do to solve 2 times x equals 100? Remember, we do the opposite operation, or to solve for x, we kind of undo, we work backwards. So what's the opposite of multiplying by 2?
Oh my god.
Dividing by 2. And if it was x over 5, okay, make the 2 go away for just a second. If it was just x over 5, Ava, what's the opposite of dividing by 5? Multiplying by 5. With a fraction in our equation, we are actually just doing both. Okay? So instead of the opposite of times 2 being divided by 2, and the opposite of dividing by 5 being times 5, we are going to do both. We're going to multiply by 5 and divide by 2. We're going to multiply by 5 and divide by 2.
So multiply the denominator and divide the numerator.
So what we're going to do, guys, who remembers what it's called when you take a fraction? Okay, my head is the 2, my feet are the 5, and then we just...
Whoa!
Yeah.
Oh my god! We gotta
So,
do.
That's
That's
what
really
you
no
see
math
what
in
it's
attention.
What happened there, Ethan? What did I just represent? Heat change flip. What do they call the flip part? The starts with an R, ends with an reciprocal. Reciprocal, right? There I am, right there. Okay. So,
Mr. Smith, you do not look like that.
kind of, a little bit, right?
You don't look like a monster. Ew, no.
Now, I know Brendan for sure told me. I think Joey told me.
I actually can't say that because I know.
A few other people figured it out and didn't say it out loud. But several people figured out, guys, that if you multiplied 100 times 5, so much funnier when the math is done. You know? 100 times 5 and then divide it by 2. Somebody else, I think it was Brendan, I think you said you divided the 100 by 2 first to get 50, multiplied that by 5.
So you flip the fraction.
Doesn't matter. You flip the fraction. You can do it in either order, really, in this case. But what's easier is to multiply top times top, bottom times bottom. Okay, multiplying fractions. We're going way back now.
Wait, but why do you flip the bottom? Why do you flip it though?
It's a good question.
Yeah.
Why do we flip it?
Oh. Whoa. What's this?
No.
because I think that's what I want right there. Okay. So, what do we want in the end? What do we want to know?
The answer.
We want to know the answer. In this case, Brody, what is the thing we don't know? Which is represented by X. Okay, Brody has correctly identified our problem. We don't know what X is. Look what this does here. When we do numerator times numerator, denominator times denominator, what is 5 times 2? What is 2 times 5?
Wait. So equals 10 times 5 equals 100% of it.
So, well, no. Kind of, yes and no. Yeah, actually that is true. What is 10 divided by 10?
1. Oh my gosh, this is the property we didn't,
Now, folks, even if it causes you to groan, you should still recognize this process. It's the giant one process. So even if it's kind of like, oh man, you at least know you've done it before. Yes.
Exactly.
So, numerator times numerator, denominator times denominator. Let's see who's up next here. Casey, what is 100 times 5?
500.
And what is 1 times 2? So, some people chose a different way to get to Florida, or in this case, I think one to Colorado. Colorado? I already did. But Jalen, what is the total distance?
Oh, okay, yeah, that's why I lived in Colorado for so long.
500 over 2, which is, what's half of 500?
250.
Well, Jalen, you get the next one. Okay. Okay. Folks, your goal now is to get the next 2 or 3 problems done in the next 10 or so minutes. I'll stop talking. I'll answer questions individually.
Are we done?
You need to. No. We are not there yet. Answer that. Okay, we're on 40. I want you to try 40. Check with me the answer, and then go on to 41. 40. Check your answer, then go to 41.
Wrong, but definitely has right.
Okay. Guys, I want you to actually go ahead and skip down to 7-42. Go to 42. Go to 42. Oh. Okay. I actually changed my mind again. Okay. Sorry. This is the last one, guys. This is the last one, so I can't change my mind. I want you to actually jump down to 7-44. Do parts A, B, and C. Check them with me, and then you may begin to work on your homework once you've been checked on those three. If you're not sure, raise your hand and ask. If you're not sure, raise your hand and ask. Solve for X.
Listen, Linda. Mr. Smith?
Yes.
I'm still like a little confused on this.
Yeah, me too. A little
And
bit.
there's no sign.
Okay. So, are you looking for A? Did you write it down? Okay. So, what's happening to you? So what is happening to
No, literally, like the bottom of my foot. I do not always. Most of the time I try. He has been Stop. That was not nice. Wait, what did you say? Oh no.
All right. Well, Mr. Smith is still helping a couple people. I gotta let him get to wellness and set up for that. So, who can summarize a little bit of what you guys did / learned today, especially this last part? I'm a little confused by what's on the screen. Who can summarize? Joey? So you talked about scale factors. What about?
Oh, reciprocals.
What about reciprocals?
Reciprocals are when the fraction just like flips.
So, like in B right there, what is your scale factor?
5 seconds.
Careful. 2/5 actually.
Oh.
In the start of the problem, it's 2/5.
Because it's when you multiply by.
It's scaling to X, right? Because it's the multiplier. The scale factor is the multiplier. But then, Joey, the 5/2, I agree with you. We brought that in, though. That's why it's not our scale factor. We made that. If the problem gives you something multiplied by something, that's your scale factor. When we do something on both sides, that doesn't count. So, big thing here, guys, that people last year did not absorb well enough, and they kept trying to divide by fractions and use their calculator. And this is when I will not accept decimal answers if the fraction way is the better way. If you get a repeating or a nonsense long decimal answer, you probably didn't do it the way you should. Reciprocal multiplication is often the cleaner route to go. So you guys haven't done 44 yet, right? Yeah, so keep working through 44 and then we'll review it real quick up here in a couple minutes. If you get 44 done, you may start either of the homeworks. That's if you get 44 done. Why, and this is an extension question, why does the reciprocal do that, like, oh so convenient destruction of the fraction? It destroys the other fraction, right? Well, how does the reciprocal destroy the fraction that I have? Why? Kevin? Yes. Does not have to do with the reciprocal. Try to use the restroom in reciprocal form.
Wait, don't you just switch to, don't you just swap to a 9?
Yeah.
But that's a reciprocal word.
I know, but why?
Well,
Aiden told me.
because 9 times 9 is 27.
Terrifying.
Wait, no, it's not. I lied. Sorry. I lied. Sorry.
So, Aiden told me
I meant 9 times 2.
swap the 9 and the.
No, it's not. It's 18. Oh my god.
Hey guys, I would be ready for me on a test to ask you to justify, like explain why you did what you did. So Aiden said swap my 2 and my 9, and I agree. And if we're going to work with fractions, we should probably work with fractions, right? But then why does this destroy the fraction? So Aiden was just saying because 2 and 9 makes.
Wait, what? Oh, 18.
And then 9 and 2 makes.
18. So equals 1.
What happens here?
It's 1.
And I want to make sure we're saying this right. It reduces to 1. I still have some people trying to tell me that this will be 0. A number divided by itself, how many 18s are in 18th? 1. Now, it doesn't delete or it reduces. That's the word we want to be using. So if you're trying to explain something, we reduce to 1. That's why reciprocal multiplication works. Now, I don't need you to defend this using the giant 1. That's not something like other schools necessarily. That's a CPM idea. But this is the CPM idea of giant 1 anytime a number is over itself, even if it's a really complicated number. So, like, one of the first problems you solved doing this had them dividing instead by the coefficient, right, which is gross. But it still makes a giant 1. And that's why we could do it. 9 halves over 9 halves. That's a number over itself. But it's not the nice way. So that's why we do the reciprocal. So, if I do the multiplication over here, what's... Ooh, I can cross-reduce here, can't I? If you want to cross-reduce. You're right, though. If we don't, it's 54 divided by 9. If we cross-reduce, this becomes 1 and this becomes 3 because we can divide them both by 9. So this becomes 6. A should have been 6. If you didn't, check your work. Now, this is written in a different way, right? The variable's on the right side instead of the left side. What? Let's check vocab here. We'll go cards. Jalen, did he call on you or not? Jalen, what then is the coefficient to the variable here? Please don't point, use words. 2 over 7. So, Greta, what would be the reciprocal to our coefficient? Sorry, what? Ooh, not careful. Reciprocal to the coefficient. So, Jalen just said the coefficient was 2 sevenths because it's a thing multiplied by x. What's the reciprocal of 2 sevenths? Now, the reciprocal. If I haven't said this enough in this class, guys, when you hear the word reciprocal, you should be hearing refliprocal. Okay, so when you hear the word reciprocal, you should be thinking refliprocal, reflip. Eva, what is the refliperical of 2 sevenths? 7 tooths. No, 7 halves, right? So, don't say 7 tooths unless you're the tooth fairy. So, 7 over 2 is the reciprocal of 2 over 7. It doesn't matter that the x is in between them now. 7 on top, 7 on bottom, 2 on top, 2 on bottom. This becomes just x. Now I got to do the same thing over here. Hey guys, even if you're not doing it, I want you to be like looking for cross-reducing because it makes your life easier. What can I cross-reduce here on the left side?
12 and 2.
12 and 2 because they're both even, right? So I can divide these both by 2. I get 6 and I get 1. Then I can multiply super easy. What's 7 times 6? 42.
We're just trying to figure out. This is not really trying to figure out x.
It's a shortcut method for solving when fractions are involved. Now be careful for all the marbles. And I don't know how many marbles there are. Brendan, what is the reciprocal to the coefficient up here? Negative what? Be careful. What did I ask? I asked what's the reciprocal. It's the reciprocal of the coefficient. So back yourself up. What's the coefficient? Negative 3/4. Hey guys, are we talking about math? You're being really rude right now. So just so you self-check yourself, like we're doing math, and this is my job, and you're just talking about them all. So just so you're aware, like that's really disrespectful. So Brendan, you said the coefficient is negative 3/4. So to destroy that, the reciprocal, negative 4/3. Be careful with the negatives. If the fraction you start with, if the coefficient is negative, so is the reciprocal. When you flip a fraction, the sign doesn't go anywhere. Now, I always just put my negative in top because I think it's easier. Your negative can be out front of the fraction, but I don't like how that looks. So that's up to you. But I, a long time ago, decided I didn't like how that looked. What would cross-reduce here?
21 and 3.
21 and 3, right? They can both divide by 3. So you don't have to do this, but it makes your life easier. Now I just have 1s on bottom.
So 7 times negative 4.
7 times negative 4. Negative 28.
This is actually very easy to cross-reduce. It's a lot easier to cross-reduce.
It's just doing work at a different time. It's like, when do I want to do my division? Do I want to divide before? Hey, we still have 5 minutes, so you can get your homework problems done. Like, you don't have anywhere to go. I'll put the homework up here.
This
I'm going to put up the other homework. I don't know what he did with it. Did he close? He must have closed tabs. Hey, so when I collect homework next Tuesday, and or for those of you that still haven't turned in chapter 6, this right now is why. Those of you that don't utilize fragments of time to get stuff done, and some of you are sitting in here having not turned in 12 assignments for me, because we collected all of chapter 6 together, and I'm collecting this week's homework next week, Monday or Tuesday at latest. Like, if you aren't staying up to date right the night it's assigned, You need to get in that habit. Step to the side for a moment, please. So you're aware